Okay, today we continue with another behavioral biometric, namely Keystroke Biometrics. So in the last class we saw the signature biometric. We saw the static mode of signature where we are, writing the, doing a signature on a paper, getting it scanned, and then comparing the images. But more popular method of signature is what is known as the online or the dynamic signature verification, where you are using an electronic pen to sign on a tablet, digitized tablet. And it's not only the signature or the structural features of the signature that is important, but the other things like how you are keeping the pen, the pressure of pressing the pen, the all those things. And these are very similar in this biometric, that is keystroke dynamics also is very similar in terms of the parameters and feature vector and so on and so forth. But generally speaking, even the other biometrics that are behavioral in nature, like, I've told you about voice or speech recognition systems. There are other behavioral characteristics like mouse movement, how you are moving the mouse, navigating the mouse, or how you are walking, that is gait, is also another behavioral. But generally speaking, all these behavioral biometrics may not have a very high, may not have a low FAR and FRR. The false accept rate is pretty high in all these behavioral biometrics. The false reject rate, the FRR, is pretty high in all these biometrics that are based on the behavior. So let us see the fundamentals of keystroke biometrics. So keystroke biometrics generally evolved from the fact that telegraph operators had distinctive patterns of keying, and I'm sure you have heard about Morse code. Many of the military communication in the past was before radio electronics, radio communication systems, mobile communication systems, wireless communication systems, satellite communication systems. Before these things were there, people were primarily relying on signaling and telegraph. You are sending signals through telegraph, through Morse code. And this Morse code is basically patterns, dots, dashes, and stuff like that. So from there, this evolved as a biometric, where we have telegraph operators having distinctive patterns of keying the messages over the telegraph lines. So this is the genesis of the keystroke biometric. People were using these things for communication, and that evolved into a kind of a biometric. And the basic idea of a keystroke dynamic or a keystroke is that, how you are typing, the pattern with which you are typing. It is not only the finger movement with respect to the typing, but how you are typing, which finger you are typing, how much time you take to search for a key, how much time you're searching for a key, how hard you press the key. All those kind of things are the basic logic behind keystroke verification. Now there is some finger, I'm just telling you, obviously there are specific fingers for different alphabets. If you have learned typing also, there is a very clear logic. Use the index finger for certain alphabets. You use the small finger, the smallest finger for AS, AS. Use the small finger for the enter key. There is a logic, but each of us has our own pattern, right? Each of us, even though that is scientifically that is the fastest way, using the correct finger for the correct alphabet. Use the small finger for A and S. Use the index finger for, say, U and Y. Like that, there are some strategies and some scientifically proven fingers, but each of us has our own method. I use 2 or 3 fingers and I am able to type very fast because I get used to it. So those kind of issues are also there. So each of us has our own pattern with respect to the keystroke, and just like the signature recognition system, there are two types with respect to the keystroke verification system. The first is static verification, which is based on a fixed text mode or your password. So you are giving your password. That password, of course, you don't change your password too much, and that password is being checked, and that is the fixed text mode. And that authentication of the fixed text password happens only at the login time. Similarly, in keystroke verification, there is a more popular method, which is the dynamic verification or the free text mode. Here you are not given the text ahead of schedule. The text is given based on some logic, but the text is given only at that time, and on the fly it has happened, and then you are typing that text. So it is not predetermined, it is not known ahead of schedule, but it is based on something that you know. Generally speaking, the dynamic keystroke verification, it is based on something, it could be based on knowledge factors or ownership factors or something unique. What is the name of your pet? What is your second email ID? What is the secret question of your password? What are these kind of questions that are known, to you? This is the text that comes onto the screen, and that is where you do this dynamic keystroke verification. Obviously, it is you know the answer for all those queries. So if you do not know the answer, meaning that it is somebody else who's getting into the system. So this is the logic behind the dynamic keystroke verification system, which is better than the static. The static, the problem is it is password. If somebody has spoofed your password, it's a problem, and that somebody uses the same fingers, again you are in trouble, right? So it is better to go for a free text or a dynamic verification, where there is a pattern is based on some knowledge factor of yourself or some ownership factor, something that you know, or something that is only inherent or to you, and you give the thing. So that is the general focus behind a keystroke verification. Now, keystroke verification is very useful, advantageous. It's a software-only method, no additional hardware except a keyboard. It is very simple to use, universally accepted, unobtrusive, non-invasive, cost-effective, cheap. You're only using your keyboard, no need of any training. It's a very simple and easy way, but obviously there are disadvantages. The same disadvantages, more or less, with respect to the handwriting. You get tired, fatigue. And again, your pattern for typing also changes, maybe not so regularly, but then over a period of time, here and there, your patterns also change. I would think maybe in a year or something, every year probably, that's my surmise, that maybe in a year your typing pattern slightly changes. Then obviously injury skill and change of keyboard hardware. Generally there is a standard keyboard, but then some manufacturers don't want to have uniformity. I mean, the keyboard that you use may be slightly different in an Apple PowerBook or an iBook and all. So those kind of issues are also there with respect to the keystroke dynamics. Now, how do you measure? What do you measure in the keystroke? How do you get the feature vector? The feature vector is based on some simple metrics for user verification. These metrics include the speed of typing, the keystroke seek time. That means how much time you are taking to seek or find a key. Obviously, when you use the small index, the small finger for A, it should take the least time. But if you are not using that, it will take more time. So based on that, the seeking time for the keystroke is a biometric. The flight time, how much time your fingers are on the air and not banging the keyboard, that is also a metric. The sequences of keystrokes, Where for pressing the enter, which finger do you use? I mean, some of us use the thumb for doing. Some of us don't use that. Those sequences, the errors and how you correct the errors, that is also a biometric. Do you press the arrow key to go behind? Do you use the mouse and touch the cursor to the point to make a correction and so on? These are the things that are the metrics for user verification in the keystroke dynamics. Now, how you make the feature vector? For, as you know, for any biometric, you convert it into a feature vector. Fingerprint, I told you, there are minutiae, ridges, and the minutiae form the feature vector. For hand recognition, I told you, you have the hand, you have some 16 measurements, from top to down width, and that becomes the feature vector. For signature, we saw, if it is the static mode, the structural features of the signature become a feature vector. Here, the feature vector is composed of certain numbers or parameters like the latency or the flight. How much time your finger is in the air and not banging the keyboard. How much time you take for a keystroke, for finishing a keystroke, that is a dwell. The pressure, how much force you are employing to press the key. The typing speed, the style of typing, the frequency of error. That's a very important feature. How many errors that come. If you are using the correct finger, errors are not likely to come. But if you are using one or two fingers, the errors will come. Those kind of things. Overlapping of specific keys combination. You are using a control shift, keys, shift keys. See, each of us has our own style. When for cut paste, copy paste, some people use Control C and Control V. I think that's the most popular thing. I don't use Control C and Control P. I use Control insert and Shift insert. I think it does the same thing. Control insert and you Shift insert. Control insert is copy. Shift insert is paste. So each of us has our own style for overlapping of specific keys and how we correct the errors also. How we take the errors. So this is how you get these are the features that are taken into account, and these are converted into a vector, and it looks at different times. A dwell time, if you see, the dwell time is the time from where you wanted to press the S to the end of the S after you printed there. That is a dwell time. There is a digraph. Digraph is the start of the first character, your keystroke, to the end of the second character. There is a trigraph, the start of the time of the first character to be entered into the keystroke to the end of the third character. That is a trigraph. And flight time is when your finger is in the air and you are not pressing the keyboard. So these are with these we get what is known as a feature vector, and then we can use different types of statistical models. We can use different kind of different types of models that we can use to be able to analyze. You can move the feature vector. You can use machine learning models, deep learning models, like I told for handwriting also, hidden Markov models, regression, machine learning techniques, random forest. All these you can take it to the next level of analysis. But since we are not learning a machine learning course, I'm not going much into the details of those techniques. Although when we are covering face recognition system, we will do a bit of techniques, statistical techniques with respect to that. So that is all from my side. I close my class. I will now take attendance. Please stop the recording.